Hello. So again, welcome to the part 2 of simplifying rational expression. So to check whether you understand how to simplify rational expression and in the part 1 of this video, so let us start with okay try this given. So you need to simplify each rational expressions. So for letter A, you have 15 over 45. For letter B, you have 60xy cubed all over 25xy. For letter C, you have 3a plus 6 all over a squared plus 2a. For last letter, you have 2x squared plus 10 all over 2x squared plus 7x plus 5. So if you'll be able to answer all of this correctly, then we can conclude that you did understand the part 1 of this video. Now, so to better give further examples, so again, so let's continue giving some examples. So for our first example, we have a squared plus 7a all over a plus 7. So again, all we need to do is to first factor out the numerator. So here you have a GCF, which is a. Factor out a, that gives you a plus 7. So all over a plus 7, you simply, again, cancel out a plus 7. So the answer would be a. Okay, so I guess that's an easy one. So how about this next example? What if you have 4a minus 1 all over 1 minus 4a? So what you're going to do is you factor out the negative of the numerator. So that would become, factor out negative, that gives you negative. So that would become negative 4a plus 1 all over 1 minus 4a. Or, let's check if this is correct. So if you're going to distribute the negative sign, negative multiplied by negative 4a, that would be positive 4a. That's correct. Negative times positive 1, that would be negative 1. Then rewrite. So negative quantity, I could write this as 1 minus 4a all over 1 minus 4a. So again, you have common numerator and denominator. So I'm simply cancel this one out. And that leaves you with a negative 1. So the answer is negative 1. Now, so remember that when the terms of two polynomials are almost the same, so like this one, 4a minus 1 all over 1 minus 4a, except for the sign, so the polynomials are called negative of each other. So this example, so this is what we call the negatives of each other. You have the same given but with different sign. So emphasizing this concept, so if you have a minus b, and b minus a, so these are negatives of each other. So we could write a minus b, then and that would become negative a minus b. So they are negative of each other, or each is an additive inverse of the other. So for the division of negatives, So for the division of negatives, okay, so the quotient of any non-zero expression and its negative is -1. Okay, so let me just write it. So the quotient of any non-zero expression and its negative is -1. Okay, so let's have some other example. Okay, so another example, let's say have here 3b squared minus 14b minus 24 over 12 minus 2b. Okay. Okay. So first is I'm going to factor the numerator. So applying what we have learned in our factoring topics. So, okay. So this gives me 3b plus 4 quantity b minus 6. Okay. So if you are well familiar with the factoring concepts and techniques, so you could easily get this answer. So all over, okay, this is 12 minus 2b, so therefore common factor is 2, then the remaining factor would be 6 minus b. Okay, now I want you to take a look at this part. Oops. I want you to take a look at this part. Okay. Okay. So you have here b minus 6 and 6 minus b. Again, these are what we call the negatives of each other. So therefore, all we have to do is to factor out the negative sign here. So this will become negative 3b plus 4, and that gives you 6 minus b all over 2 quantity 6 minus b. Now, as you can see, after factoring the negative sign, so we can cancel out 6 minus b. Okay, and by distributing the negative sign on the numerator, that gives us negative 3b minus 4 all over 2, and that would be your final answer. Okay, so okay, so it's time for you to simplify this given. Okay, so again, it's your favorite part, the try this part. Okay, so for letter A, you have x squared plus 8x all over x plus 8, and for letter B, you have gx minus 2 all over 2 minus 3x. Oops, sorry. Okay. Then for letter C, you have 10a minus 2 all over 1 minus 5a. Okay. Okay. One of the application of rational expressions is usually in rate problems. Okay. So are you familiar with rate numbers? Rate problems. So when we say rate, so this is expressed as a ratio or fraction. So for example, okay, so I'm giving a first example. So if Ben drives let's say 200 kilometers in x plus 2 hours, then what is his average speed? Okay, so well, this is some sort of science thing. So well, as you all know, okay, math is the language of science. So therefore, I know that we can be able to solve this problem. Okay, so if Ben drives 200 kilometers in x plus 2 hours, then what is his average speed? Okay, the important thing here for us to be able to solve this problem is for us to determine, okay, the correct formula for speed. Okay, so well, again, the formula for getting the average speed, or simply speed, okay, that is the distance traveled over time. Okay, so simply substitute the given. So distance, okay, in the problem, okay, what is the distance? So okay, we have this keyword kilometer, so therefore this is our distance. Okay, so we have 200 kilometers. So how about time? So that is all over the time. So we have here the keyword hours, so this will be the time, so x plus 2 hours. So therefore, okay, Ben is averaging, okay, 200 all over x plus 2 kilometer per hour, or kph. Okay, so this will be your final answer. Okay, another problem. Okay, so another problem, say if x plus 5 kilos of mangoes cost 150 pesos, okay, then how much is the cost per kilo? So again, if x plus 5 kilos of mangoes cost 150 pesos, then how much is the cost per kilo? So for the solution, okay, so again, just follow what is being asked. Okay, so that is the cost, okay, per kilo. So what is the cost? So what are the keywords? So where are the keywords? So here, cost refers to money. So this is our keyword, cost. How much? That is 150 pesos all over kilo. Okay, so you have here the kilo. So that is x plus 5 kilos. So this will be your final answer. So cost per kilo is 150 pesos per x plus 5 kilos. Okay.